Hi, in this screencast we're going to be looking at fractions. Specifically, we'll look at finding equivalent fractions, simplifying fractions, and then performing operations, multiply, divide, add, subtract with fractions. Just intended to be a quick review of things that hopefully you're fairly familiar with. To begin with, if I'm looking for an equivalent fraction, it means it's a fraction that means the same thing. It might be expressed differently, but means the same thing. So if they say write a fraction expression equivalent to 3/4, so here's 3/4, but it says it has to have a denominator, that's the one down here, to be 8. So if this 4 I've got to change to 8, this top number can't be 3. Can't be 3. It has to be something other than 3 because I changed the bottom. So when you're finding an equivalent fraction like this, you'll see, well, what did you do to the 4 to get 8? And in this case, I multiplied by 2. If you multiply by 2 in the bottom, thou shalt multiply by 2 on the top. So 3 times 2 would be 6 over 8. So 6/8 and 3/4 are the same. If you do this on the calculator, go 3 divided by 4, it gives you 0.75. If you divide these two on the calculator, it also gives you 0.75. So they really mean the same thing. But the question here is a good one. Why would you actually want to do that? Turns out that if you're adding or if you're subtracting fractions, being able to write equivalent fractions is a critical step in order to be able to add or subtract. Initially, we just add and subtract with numbers, and probably lots of them you could do on your calculator, but eventually we get adding and subtracting fractions that don't just have numbers, that have x's and other things. So you need to understand the concept behind how you get equivalent fractions and why you would do that. So here's an example of looking at other equivalent fractions. Equivalent fractions, not only can you make go bigger like this, that we often do when we're doing fractions, but you also need to be able to simplify an expression. So here I have 8 over 12, and I need to make that into an equivalent expression. I notice that both the 8 and the 12 are divisible by 2. They're also divisible by 4. Maybe I'll use that to start off. So 8, I could rewrite the same thing as 4 times 2. 12, I can write the same thing as 4 times 3. Those are exactly what I have over here. 2 times 4 is 8, 3 times 4 is 12. But if I have 4 and 4, here's a fraction, I could rewrite this fraction as 4 over 4 times 2 over 3. Notice I'm collecting these ones that are exactly the same because anything divided by itself is just equal to 1. So 4 divided by 4 is just equal to 1. So I have 1 times 2/3, and then anything multiplied by 1 is just itself, right? So it's 2/3. So this fraction here and this fraction here, those two are equivalent fractions. If I'm given an answer like this, I always want to simplify it to an equivalent fraction that's in the simplest form possible. Okay, so here's another couple of examples. So 15 over 20, I can write that as 5 times 3. The bottom I can write as 5 times 4. Hey, the 5's match up, so that's 5 over 5 times 3 over 4. And 5 over 5 is 1. 1 times 3/4, of course, is 3/4. Now, these steps in here, and even some people, I'll do this in red or red another way. Some people can actually even look at 15/20s and say, hey, well, 5 goes into both of those. So 5 goes into their 3, 5 goes into their 4. See how you get the same answer? And if you do it that way, that's perfectly fine too. Some other people like to at least do part of it and rewrite it like this, and then say, hey, 5 over 5 is 1, so those cancel out, often is the word that people use. And so if those cancel out, then my answer winds up to be 3/4. Whichever way that works for you, you can do it that way. Maybe pause and try this one on your own and see what you come up with. And when you press play, I'll reveal the answer and see if you got the same thing. Okay, hopefully you've got it done. That's sort of what I did. But again, like before, you could maybe simplify and say, hey, cancel those. Your answer's 4/5. Or you could have said 3 goes into there 4, 3 goes into there 5. Your answer's 4/5. Either way, whichever makes sense for you. There's just another quick example. Let's now turn our attention to operations. So we're going to be multiplying, adding, dividing, and subtracting. One thing with fractions, you've got to make sure that when you're doing the operations, you identify which operation you're doing, because there's different rules. Adding, subtracting, I guess, are basically the same rule, although you add or subtract the numerators. But multiplying and dividing, they're slightly different. And there's a big difference between multiplying and dividing and adding, subtracting. So make sure you know which one you're doing when you're doing the question. Okay, so let's try a couple. Here's one where we're multiplying. So if I'm multiplying these two fractions, what I want to do is multiply the top and multiply the bottom. So 4 times 1 is 4, 7 times 2 is 14. Now, I'm feeling pretty good with that answer, but I notice that each of these, so each of those numbers could be simplified. So I could do that again, that equivalent fraction thing. 4 is the same thing as 2 times 2. 14 is 2 times 7. 2 divided by 2 is 1. So I can eliminate that, and my answer would be 2 7s. I was going to have you try this one on your own. You can take a look to see how I did it there. I just left the 12 alone because I saw a 12 here and a 12 there. And so I left those alone. 10 I simplified, or I rewrote. 25 I rewrote. And then here I've got 12s, so I wrote them there. I've got 5s, I wrote them there. And then I have left over a 5 and a 2, and I rewrote those there. These are each factors of 1 that I can eliminate. And so my final answer would be 5/2 or 2.5. Either of these answers are acceptable. In dividing, slightly different rule. When you're dividing fractions, what you need to do is first change the divide to multiply and then flip this one over. They call it invert and multiply. So this would be 15 over 12. Again, the 12s are the same. I could rewrite those as 12 over 12 times 15 we'll write as 3 times 5. 10 we'll write as 2 times 5. So the 12s are a factor of 1 that gets eliminated. The 2 5s are a factor of 1 that get eliminated. So I could write that as 3 over 2. Again, I could rewrite it as a mixed number if I wanted to. Here's one to try. Pause, try that dividing, see what you come up with. Then press play to see the answer. That's how I would have done that one. Hopefully it came to 2/3. Now, when we're adding and subtracting fractions, the first thing we need to do is get a lowest common denominator. In this first question, it already has a common denominator. The denominator is 10. So all I really have to do is add the two top numbers. So the numerator, so 3 plus 5 is 8. Again, 8 over 10 is the same thing as 2 times 4 over 2 times 5. The 2's are a factor of 1 that get eliminated, so my answer is 4 over 5. Always make sure that you simplify at the end. If you give me this answer on a test, I'll say, hey, great job, but you could have simplified, and you'll lose a few marks. Here's a question where I have 12 over 10 plus 12 over 15. I don't have a common denominator. So I need to get a common denominator. And I can do that whole thing where I do the factor tree. So 10 is 2 and 5. 15 is 3 and 5. Those are my prime factorizations. So I need at least 1, 2. I need at least 1, 5. I need at least 1, 3. So 2 times 5 is 10 times 3 is 30. Therefore, my lowest common denominator is 30. So I can do this if I want, or if you can just look at them and say, hey, the lowest common denominator would be 30, That's fine too. To change from 10 to 30, I needed to multiply by 3. So I would do the same thing on the top. 12 times 3 is 36. 15 to 30, I'd need to multiply by 2, so I'd need to double this top thing, or 24. Now that I have a common denominator, I can keep the denominator the same and add the top two. The top two come out to be 60. Oh, that's interesting. And 30 goes into 60 2 times, so my answer to this question would simply be 2. Again, pause the video and see if you can do this one here. Press play again to get the answer. There we go. Hopefully you came up with 7/5 or 2 2/5. When we're subtracting, exact same thing, except to subtract the numerators. In this case, the denominators are the same. I subtract the numerators, done. This one, denominators aren't the same. I need to get a common denominator. Between 7 and 2, the lowest common denominator would be 14. So they each need to change to 14. This first one I can times by 2 to get 14, so I have to multiply the top by 2. The bottom one I have to multiply by 7, this 2 by 7 to get 14, so I have to times this by 7. And if I'm subtracting, I keep the base the same and simply subtract the numerators. Again, try that with this one and see what you come up with. And then press play to see the answer. Hopefully you came up with 5/12. Okay, just the last slide on here, and I've sort of done it already. It's just a quick review of converting from a mixed number to an improper fraction, or from an improper fraction to a mixed number. To do this top one, to convert from a mixed number to an improper fraction, and these ones, although they say improper, this is sort of where we want to be. That's often the type of number that we like to have. In order to do that, you take the whole number here and multiply it by the denominator. So 2 times 5, and then you add the 4 on top. So 2 times 5 is 10, plus the 4 is 14/5. If I have to go the other way from improper to mixed, then instead of multiplying here, I divide. So 7 divided into 9 goes once, and then I ask myself, if I divide that, how many are left over? So 7 into 9 goes once with 2 left over, and you keep the denominator the same. Okay? All right, so in just a quick summary for this section, we looked at equivalent fractions, and we also looked at simplifying fractions. That's an important thing that you need to do every time you're dealing with fractions. And then we went through and did the multiply, divide, add, and subtract with those fractions. Hopefully that quick review helps you out.